Alright, so now let's make something very much like greedy, but the exact opposite. Let's make something lazy. So let's add a new class. This will be lazy, C#. I don't know what these are, it's gotta go. Okay, and lazy is a subclass of repeat. And let's generate the constructor. And in fact, the constructor is going to be identical to this. In fact, I'll take all of this stuff here. And I'll put it over here. And this is just going to be called lazy. Alright? Alright, seems good so far. Don't actually want this. Okay, so, well, I tell you what, we can get the match done pretty quickly here. Override, match, context. So if, and this is again very similar, if not base.match on the context, if it doesn't match the minimum number of times, then we've failed. Okay, so it has matched the minimum number of times at this point, but I am lazy. So let me just tell, let me write down how many times I've matched, optionally, none, and call it good. And that's laziness for you. That's pretty much it. And this is literally exactly what's going to happen. So that one's pretty uninteresting. But, I'm sorry, override, match next is far more interesting. So, let's talk about what needs to happen here. Alright, well, I guess the first order of business is I should pop that back off the stack. Alright, pop. So far so good. So that's how many times I matched before. And then there's a couple things to think about. So I've been backtracked into, and the first thing that happened is I tried not to do anything. And I successfully did that. So the first order of business would be to try and see if I can match at this point, right? Because reluctantly I will try to do a match. So if, well, if the index, let's be sure that this is in range, is less than max, and match item matches in this context, then I will context.stack.push ++ index, and then I will return true. I want to do the absolute least possible, right? This is the lazy behavior. Okay, so, well, what can we do? So this is one of the fundamental differences between the greedy and the lazy, is the first thing it's going to do during a backtracking operation is say, all right, can I just reluctantly match again? And it will continue trying to match and incrementing this value on the stack. If we come in here and you pop something off the stack and I'm already at the maximum, right? Then I'm out of options matching here. So what I need to do is start backtracking. So I will say the following. So while index is greater than 0, I'm going to start backtracking. So if it's the case that match item dot match next succeeds in this context, right, then I'm good to go. So then I will just say context.stack.push, and I will push the index back onto the stack because it is the index that is how many times I've matched, and we'll return true, right? And then otherwise, index will just get decremented like that. Okay, so this loop here ensures that, this is kind of the other way that's sort of nice mentally to make sure that the algorithm even makes sense, is that I must be issuing a match next on every single iteration, right? Every single instance of that token in order to correctly fail out of this loop, just because the state and everything has to be restored, right? So the first thing I do as a lazy operator is I try and just keep matching if I have more options. If I don't have more options, then I will go backwards through the number of iterations until I find one that does match, and if I have an alternate lazy match, then good to go. If I don't at all, this will decrease all the way down to 0. And at this point, I need to go back into the required ones, right? So if this was A24 but lazy, then I would have tried all my alternatives and I would have nothing here. So at this point, I have no choice but to say if, well, I have no choice but to go back to the base level, right? And just repeat these guys. So if that fails, then it should have reset everything itself, and we are completely out of luck. However, if that succeeded, then that's just like matching right here, right? The base level matched. I found a match at the base level, so let's just be lazy. Dot stack, dot push our 0 right back on there, and return true. Right? That's as lazy as we can be. So I'm going to completely change what I said before. In retrospect, this one is a lot more complicated to get right. I think that getting the backtracking to work the way that it actually is supposed to work is difficult. And I went through several iterations of trying to write this the correct way, and they were not correct. So that's that. So why don't we just duplicate this method here and try it with, well, we'll just do a match lazy test, right? This will be lazy test 1. And I'll just change this to be lazy. Okay? And so we expect to get exactly match greedy test, but kind of, I will say, quote, opposite order, right? So let's go over here and say match lazy test 1. Okay, so matching lazily, let's flip back so we can see what the thing was. 2 or 4 times, okay. I matched it twice, which is the least I could possibly do, that's the minimum. And then I bailed, so we're good. Then match next, said, all right, fine, I'll try and match it again. And there's the 1 optional, there's the 2 optional. Match next again, nope, I'm already capped out. Let me go backwards and see if there's alternatives. There are not. The entire thing backtracks to the base level, which backtracks all the way to the beginning. Stack is cleared, everything looks good. And I know I'm going through this fast, but frankly, you can rewind and rewatch the videos, and that's a lot better than having like a 15-minute video where I repeat everything a bunch of times. But if stuff needs to change, then you can either leave me a helpful note that describes why and how, or you can get over it, because I'm doing it for fun. So, okay. Lazy. All right, so this is going to be the same thing as before, except it's going to be matching alternates lazily. So let's do this guy. Let me flip over here. Match alternate lazy test, like that. And let's run it. And what do we have? Okay. So lazily match this 2 or 3 times. Okay. So because this is AA at the beginning, the least I could have done is matched it twice, and I did. And so that's 0, 0, 0 for alternate, alternate, lazy. And then we backtrack into it, and we say, do you have an alternative? And it can't match again, which is its first thing that it tried. And so it goes back to the token and says, do you have an alternative? It turns out it does, and that is to match 1 less item, right? That's item number 1 here. And so then we behave lazily again and say, cool, we're good, right? Take no more options. And then now we get forced to match next again. And the first thing that it's going to do is try matching some more, right? So it's going to run this token again. This token matches on index 1, which is the single A. And then we have lazily matched 1 optionally. And so this one comes from the lazy. And of course, this can backtrack again and blah, 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 blah. And there you are. Right? The very last case here is I've matched it all 3 times, right? So the 2 minimum plus the 1 optional. And I've forced myself all the way into the final case for each alternation. At this point, there truly are no more options and the complete list is exhausted. So that is that. Okay. Okay, so this video is already 10 minutes. Let's wrap this guy up. And I think next what we're going to do is capture groups. And capture groups are going to take a few videos because there's a lot of little details that come up with capture groups. But at the end of it, it's going to be pretty sweet because then we can start doing things like back references and other kinds of fun things. So that will be where we're headed next. All right, later.